Hi everyone, I will be explaining Einstein Discovery as part of this video and how it is used to create the models behind the scenes. These days, almost all of the businesses have access to the data, but they don't know how to figure out the meaningful insights of the out of that data. So let's take one example of deal closure um, where we have a business and we want to identify if the deal is going to be closed or not. And that's going to be a very important step for us to identify like what is the probability of deal getting closed. If we get that information on time, then we can take actionable steps to get the deal done. That's where Einstein discovery is useful because it not only identifies and visualizes the insights, but it predicts the future outcomes and suggests the ways to improve the outcomes. So if we use Einstein discovery in our use case, so it's gonna help us to predict if our deals are going to be closed and what would be the steps which we can take to improve that likelihood of deal conversion to improve. So I'll be explaining this whole process using a chart which I have created. So I'll be walking through this chart from left to right. So of the boxes which you can see on the left hand side, that says that we will be getting data from various sources. Now then there could be a scenario where we could have data in various different sources or in different Salesforce orgs. So we will have to get all that data using CRM analytics, where a lot of connectors are available from where you can connect with Amazon S3, you can connect with Snowflake, other Salesforce org, or the org in which you are building the discovery. So whatsoever is your third party application, you can build the connections using the connectors which are available in the CRM analytics. Even before feeding that, you can do the data cleansing part, data wrangling part using third party tools. Or if you don't want to use third party tools, then we have a lot of other options inside CRM analytics through which you can transform your data. So we have recipes, we have data flows that are used to create data sets. Once we have data sets in place, then we can feed those data sets in Einstein discovery. That's where the model creation parts come into picture. When we start creating models, then it first asks like what is the outcome which you want to improve or which you want to predict. So here it is, in our deal closure scenario, it's if the deal is going to be closed or not. So that's what the outcome which we want to improve, likelihood of the deal closure that we want to improve, and we want to predict if the deal is going to be closed or not. So that's what the outcome is. And we could use a lot of variables over here, like for how long the customer is with us, how active the customer is, how many assets customer has purchased from us before coming for this deal. So there are a lot of other parameters which we can use to train this model. These variables are known as predictors, and the outcome which we want to predict, that is known as prediction. Now based on the type of outcome which we are talking about here, the discovery creates model based on that outcome. So these models could be of three types, like it could be regression, binary classification, or multi-class classification. So the example which we are talking about, that's a use case of binary classification because we have just two choices: either deal is going to be closed or it's not going to be closed. But if in case we have more choices than two, then that's a use case of multi-class classification. Now there is one more type of model, that is regression. So if in case you want to predict some quantitative measure, so let's say how many products a customer is going to purchase, so that number, that's the quantity, so that's the regression model. But we don't have to worry about this because behind the scene discovery handles this for us. It's just we will have to feed in the outcome, we will have to give correct variables. Once that is there, then it generates a performance metrics, or it is known as quality metrics. So it this is where we will have to work to tweak our variables, to change the number of variables, or to get correct data into the model. If the data quality metric shows that your data is not good, or it has some bias, there are duplicates record present, there are highly correlated data present, so then in that case it will show those parameters, how you can improve the quality and what are the measures which you can take for that. So once that is done, so again, this is again known as data alerts as well. So these are sort of alerts which you will have to make sure that you get rid of those alerts to get good data. Once this analysis is done, then that's where we get our insights on the data. These insights could be descriptive, diagnostic, or comparative. So it's like what happened, why it happened, and what is the comparison if we use different sort of variables. This will give us the predictions and the improvement areas. Once we get good data quality, we are getting the predictions and the improvement areas which you think is right and is predicting correctly, then we can deploy this model, and post that these predictions and improvements can be embedded into your lightning record pages in experience clouds or in the flow builder. So other than that, these predictions and improvements can be accessed via apex calls, or you can say rest apis. Then another good use case where you can use predictions and improvements is inside Tableau, where you are already analyzing your data, and then you can embed your predictions as well along with that. And you can have your predictions and improvements running over your reports as well. So it Discovery deeply analyzes your reports data. It builds the charts, correlations, it builds the patterns, like what is the type of data which is present in the report, to give you meaningful results. So yeah, that's it about Einstein Discovery. In the next session, we will create one model, and we will see like how it looks like. So that's it. Thank you.